Hello guys, welcome to this fourth and last video. So in the previous one, we end up having our surface already subdivided into what will be the panels of our design. So the next thing we're gonna do here is to start creating the structural grid following this same subdivision. So I'm gonna start by calling a divide surface component here. And I'm going to connect it to my loft component I have already here. And I'm going to set up these two values. I'm going to plug it with the same sliders I have for my divide domain component that I have here. And as you can see now, I have a grid of points that matches with my surface subdivisions. Now we're going to use these points to extract some isocurves from our surface and create some structural elements with them. So the first thing I'm going to see here is how my information is organized. So I'm going to call a param viewer component. And I'm going to plug it to my output UV, which are the surface parameters I'm going to use for my isocurves. So as you can see here, our points are organized in a matrix, or what it's called a nested list, which means that we have a list of 61 lists that contain 18 elements inside each one. So that means that for each element I set up in my U domain, a new list will be created here. And each one of these lists will contain the same number of elements that I set up in my V value over here. Well, actually, it will be the same value plus 1, as the 0 is also taken in account here. So now, as I said before, I'm going to go ahead and extract some isocurves with these points. For those who don't know what an isocurve is, try to think of them as the curves that follow the U and V directions of our surface, which would be these lines that we are seeing here. So let's start with the isocurves in the U domain. And to do that, basically what we have to do is to retrieve one of the row of points that we have in this direction. So I'm gonna go ahead here and call a tree branch component to retrieve one of the lists that we mentioned here earlier. And I'm going to set as my data tree the group of UV parameters that I have. And for my path, what I'm gonna do here is call an item component and set my index to 0. I think it's okay, and retrieve the first path that I have here. So I'm going to plug my component here, and then of course I'm going to set up this path to my branch. And now, as you can see, I have a set of UV parameters that I can use to feed my isocurve component with and start extracting, of course, my isocurves. So I'm going to call an isocurve component, and for my surface I'm gonna use I think I'm gonna use my loft that I have over here, and for my UV coordinates I'm gonna use the ones that I retrieve here. And now I'm going to hide some of these points so we can actually see better. And I'm also gonna hide my subsurfaces for a moment here. And now, as you can see, we have our curves going on the U domain of our surface. Now I will go ahead and extract the isocurves in the V domain. And to do that, this time I will need to retrieve a row of points that go on this direction. So what we're gonna do here is to flip our matrix. So as you remember from our param viewer, the way our points are organized is in 61 lists that contain 18 elements in each one. So as what I want to have is a row of points in this direction, what I need to do is to invert this logic. So what I need to have is 18 lists with 61 elements inside each one. To achieve this, I'm just going to call a flip matrix component. Sorry, I'm going to connect my flip component to my UV parameters that I have here. And now, as you can see, I have a different data configuration in which now I have 18 lists with 61 elements inside each one. So I'm going to do the same that I did here. I'm going to retrieve the first path that I have, and then I'm going to call a tree branch component again, and this time I'm going to specify this path, and my data tree is gonna be, of course, the flip component that I created. And then I'm going to again call an isocurve component here, so I'm just gonna copy this one and plug it to my new UV parameters. So remember, this is the isocurves in the U domain, and these will be the ones in the V domain. So I'm going to call a couple of curve parameters just to retrieve the curves that I need from each one. And then I'm going to hide these two. Sorry, this has to go to the p value. Okay, something like this. And now, as you can see, I have my curves in the U direction and my curves in my V direction. So next thing I can do here is to call a pipe component to start creating the structure elements. And I'm going to call a slider to set up a radius for those pipes, and I'm going to set those to 15 centimeters perhaps. And I'm gonna do the same for my curves in the other direction. And now, as you can see, we have started to create our structural grid. So now I'm going to go ahead and add some diagonal elements in these parts. So to do that, I'm going to go back to my subsurface component that I have here. And then I'm going to call a decompose sorry, no, it's a brep component command. This guy that I have here. Okay, so what this component does is to give us different information from a brep, in this case our subsurfaces that we have here, such as, for example, the faces, which are the surfaces, the edges of our breps, and the vertices that we may also have. And in this case, we're going to actually be using the vertices of our breps, which are the corners of each subsurface. So I'm going to go ahead and call again a param viewer just to see how this information is organized. And as you can see, I have 1020 branches which represent each one of these subsurfaces that I have here, and inside each list I have 4 elements that represent the vertices of each surface. So what I want to do is to create a line that goes on each surface from this corner to this other corner that I have here. So to do that, I'm going to call some list items component, and then as you can see, it's already retrieving the index 0 from each list. So then I'm going to go ahead and copy this item, and then I'm going to set another integer here, and this time I'm going to set it up to the number 2, and that should be the opposite corner, because the numeration starts normally like with the 0, and then it should go the 1, and then the index 2 would be on this corner, and the index 3 would be on this one, or perhaps it's on the other way. It depends on how the surface is arranged. Okay, so now what I'm gonna do is to create a line with 2 points, and of course I'm going to use these points that I have retrieved from my item index. And now, as you can see, I have a group of lines just how I needed them. So next thing I'm gonna do here is again to call a pipe component, and I'm going to set it up to the same radius that I have here. Well, maybe I want this radius to be a little bit smaller, as this would be a secondary element. So what I'm gonna do here is on my radius input, I'm gonna add an expression and say whatever goes into my R value divided by 2. Well, maybe that's too much. I'm going to say 1.5. Okay, that looks much better.